Okay, so I'm going to now solve the actual problem we're interested in, the nonlinear problem. So this is the third time I've recorded this lecture. I'm starting to get a bit frustrated. So I'll probably go through it at breakneck speed because it gets easier and easier every time you do it. Let's hope this works. You're not hearing me going, oh, if you're hearing this, then it must have worked, mustn't it? Okay, otherwise I would be going, I've recorded it 4 times. So here is our equation. It's not dx. The rho dx equals 0. And we have initial conditions that rho of x comma 0 equals rho naught of x. Okay, so we're going to do characteristics here. So we've got the curve x of t. So we want to work out what the absolute derivative of the density of x of t comma t is equal to. And that is of course equal to, now we do the derivatives, so we get d rho dx times dx dt plus d rho dt. That's before. And then d rho dt is of course equal to minus cp dx times d rho dx. So we get dx dt times d rho dx minus, I am going through this quicker, I'm sure of that, minus c of rho d rho dx, which equals dx dt minus c of rho times d rho, d rho dx. So we still haven't determined what c of rho is. That depends on some choice that we're going to make, right? Okay, so we've left that choice open, but what we've got here is that on the curve, dx dt is equal to c of rho. Rho is a constant. And if rho is a constant, that implies that c of rho must be a constant, which implies that the characteristics are straight lines. It's very easy to think at this point that the problem's solved. So you've got a whole lot of straight lines. So what do we know? We know that the lines are given by x of t equals the initial x plus t times c of rho of x naught times t. So if we draw a picture of it, here's t and here's x. We've got a whole lot of straight lines of different slopes coming out of here. So the solution can be carried forward along these lines really easily, but it can't be carried backwards. And there's a bit of a problem because sometimes the lines can cross, and so we don't know what the solution really is. And that's what it gets really interesting. That's where a shock forms. And we're going to talk a lot about that in the next this lecture and the next one about nonlinear shallow water waves. But there's the thing there. Okay, this is the shock. This is the idea. They're all straight lines and the solutions carry forward. So I'm going to just clear this. So we've got this expression here. We know that rho of x comma t is equal to rho. Now I gave you that formula for x. It's x naught plus c of rho of naught of x naught times t comma t. That is equal to rho of x naught. So that's the sort of equation here. We can actually draw that, and I'm going to draw you a picture of that in MATLAB in the next video, and I'm going to stop this one here.